Hi, everyone. So I just wanted to take a minute while you're all getting seated, but I would like to introduce Jeff Sorrow and Jim Lewis, who are discussing measuring tech savviness with y'all. Thanks, everyone, for coming, and enjoy.
All right, thank you, Carolyn. All right, so get started talking about, thanks for coming today to learn about tech savviness. Now, I'm willing to bet most of you don't know Jim Lewis, so I've had the pleasure of working with for a while, but you might be looking at him and thinking, that's probably a boomer over there. I have teenagers. Even if you don't, you might know the phrase, okay, boomer. Well, loose association, maybe a derogatory term, often in reference to certain tech savviness or technological things. And it's kind of a crude way of discussing somebody's tech savviness. But what you might not know about Jim is he also happened to be somebody who worked on the very first smartphone back in the early 1990s. This is a picture of the commercial at the time, the early 90s, still kind of some 80s hair around there, but that first smartphone was out, Jim, right? This is another picture of you at the conference building the Simon that first.
Yeah, that's the announcement, 1993. So if you're not familiar with the Simon, it's because it's one of those things that was successful from a user experience point of view. Won Comdex, if you're familiar with the Comdex conventions, Popular Science, Best Product of Year, things like that. And yet it lasted less than a year in the marketplace. Now, I think that probably had nothing to do with the user experience, but had more to do with the fact that three companies were collaborating on it. One was responsible for repairs, somebody else for manufacture. I actually had one. One of my kids stepped on it, cracked the screen. It was a nightmare to get it fixed. So, and it was expensive. And it was trying to do things that is with a smartphone on a non-digital network. So you can imagine the challenges. But I'm smiling there. I just like to, I had no idea what the future held. But the story I wanted to share with you about that, in case any of you are ever working with people for a demo for a new product, because sometimes the user experience person may be called upon because the interface way better than anybody else, and are better explaining it to, say, a Bell South executive. So the Bell South executive that I was working with, one of the great features of this phone was you could send and receive faxes. Just imagine that. Sending and receiving faxes. You could scrawl a map on it and then fax it to somebody else's assignment or to a fax machine. So they were set up to demonstrate this really, really great 1993 technology, and it wasn't working. And the night before it was going to be announced, I was going over this with the Bell South executive, everything else that we were going to do, while the guy coding the fax routine was still working on getting the bugs out of it. And then finally, they said, okay, we think it's good to go. He took his Simon, scrawled something on the screen with the stylus, sent it to the fax machine, and we all were, sitting there in anticipation. The machine sprang to life. The paper came out, and I went over and got it for him, and I glanced at what he had scrawled. Said, "I'm scared." Anyway, that's...
Yeah, so obviously we're not introducing a new smartphone today, but the story is twofold here. The importance is, number one, maybe age is not necessarily the best predictor of tech savviness. Jim is a pretty tech-savvy person, a little bit older. But number two, it also reminds us that we're all in the business of often assessing interfaces, especially new interfaces. And we want to know how much of the struggle are we seeing? Is it because of the interface, or is it because maybe a certain ability of the person who's actually testing the interface? How can we disentangle those two? So for quite a while, the ability to consistently and reliably measure tech savviness has been something important for US researchers, but we certainly struggle with it. And that's what we're going to talk about today, is how we go about measuring tech savviness. And we're going to tell you about our journey because we don't want to save all the interesting things. We want to say the interesting things at the end, not just spoil at the beginning. We want to show you all the things that we tried and how this is important. measure tech savviness. So join us today on our 8-year journey. Now it's 9 years since we submitted this last year. So we're 9 years into this journey. First of all, again, thinking about why you want to measure tech savviness. We don't measure users, right? We measure interfaces. So why do we need a measure of tech savviness? And then multiple studies over those years and how we've gone about the process of validating the tech savviness measure. So why do we care about tech savviness? As you saw with the anecdote with Jim, we want to be able to differentiate between first people's ability or lack of ability working with an interface and the problems that actually are occurring. Because I don't know if you've had this experience where you identify a series of usability issues. The stakeholders that conversely, the people you're using to improve life for your interface. Like, how are they getting this result? Maybe you're something for well-trained. But how do you quantify that? How do you differentiate that? So you can disentangle that from your particular data there. So you want to know essentially how much of your metrics are due to the interface and how much are necessarily due to the particular person there. So it's something that can be used both in recruiting and something that can also be used after the fact to differentiate your metrics there from those. So let's go back in time to the history of tech savviness when we started down this journey about wanting to have that measure. What we found in looking at the literature is there are really kind of 3 ways. When you think about how do you know somebody's tech savvy, there's really kind of 3 ways. It's essentially some measure of knowledge or what somebody knows, assess them, quiz them. 2 is what people report doing. Somebody report doing activities that we would consider rather tech savvy, fixing technical things, digital aspects of things, or having somebody rate their particular set of things. This is one we probably see most their attitude towards their own tech savviness. So all seem to have promise. So when you look in the literature going back, we found that back in the 90s, there were some. So anytime you want to start the process of validating somebody else, there wasn't a heck of a lot out there, despite the large improvements in technology. So a lot of the ones that we saw, one, like this Windows 3.1, it took a long time. A lot of the folks didn't actually publish the particular items. We couldn't reuse and actually test those on our own apps or own devices. On this other one, the computer experience for older adults, specific to that particular population, also took 20 minutes to administer. So I don't know about you, but we're in situations with our studies, we have so little time. We want to spend the time identifying particular problems or having those tasks. We can't have them take a 20-minute questionnaire to measure tech savviness, something that's ancillary to what we're doing in the first place. So not too great there. More recently, there were some questionnaires we found. Something that's probably similar to what you might have seen if you wanted tech savviness. People consider me tech savvy. I consider myself tech savvy on rating scales. So some good candidates here. Other ones here as well. Very little was published on the validity of this, right, Jim? I don't think there's much we can.
Right.
Yeah. So what one we did find was referenced a lot. If you're familiar with Pew, they're a large clearinghouse and organization that works on a lot of political polling and public interest research. They actually have something called a digital savviness classifier. It's just these 2 items, basically asking people how often they use the internet and how confident they are in using it. A pretty low bar, I think, particularly often measured having people who are on an online panel and so forth. It's like, well, they're probably using it. So it didn't seem like it was going to necessarily differentiate. A quick valid measure is when you want to differentiate. Something that we can start with. So look at the literature. Unfortunately, this time not terribly helpful. Essentially, what we found was reinforcing the idea that our measure of tech savviness should be some aspect of what people do, what they know, how it's worded, and those published studies were had shortcomings with the length of time and their ability to actually correlate outcomes. Ultimately, we want a measure that shows what we see when we see tech savviness not happening. There's a measure that predicted it. So, reason for more research there as well. Okay, so good excuse for us to start doing our own research. That's what we do at Measuring You. So we started on our first journey, our first path back in 2015. You get extra credit if you get the reference to that. So research of tech savviness another measure in 2015. So this first study, we had 271 participants using an online panel. We used those 3 approaches. We quizzed people, asked people, okay, answer these particular questions. what is a Blu-ray? What is voice over IP? The second one was we asked people activities. Which of these things do you do? And then finally, we asked people to self-rate on a rating scale. How technical savvy are you? Seems like a good place to start. So here's some example of a couple of those particular items. What's an ultrabook? It's 1080p. So now right away, you should see maybe one of the shortcomings of trying to come up with technology. We wrote this in 2015. Ultrabooks were all the rage. I'm sure after the ultrabook, it's kind of merged into something else. 1080p, it's like, no one talks about 1080p anymore. It's 4K and 5K. And here lies the problem. We have to come up with these nice little quizzes, and you have to kind of maintain it. And the technology was shifting. And so we were struggling, I think, with already coming up with something that was particularly working. The second thing, this is actually the number of times people are getting it right from the participants that we're using here. You'll notice people know what a Blu-ray is. I mean, that technology also is almost getting over megapixels. So you had some differentiating down here for these two particular questions, but not a hell of a lot of differentiation from what we were looking for there. So not great for the quiz. We had that maintenance issue and the differentiation. The activity checklist was interesting. Setting up a new phone, installing new software. This is just a simple checklist. Can you do this? Can you not do this? These are the percentage of people that were selected that they could do it. So we had a little bit more differentiation down there. Can you program in Java? Can you program in HTML? Real differentiators. Diagnose network problems using Excel formulas. But still not as much in a lot of the ones in the earlier on that I think we. But maybe showing promise there. And then the rating scale results showing the kind of classic positive skew that you get with the classic skew that people giving positive response there. That's not necessarily bad. It just shows us where things were. So what we then did is we wanted to see how these measures corroborated with each other. How did people's attitudes and their quiz results and their activity checklists work in tandem with each other? I'm going to use this one instead. All right. All right, so we got the correlation here. So you can see the quiz and the ratings going up here. This little R you're going to see throughout. We're going to go little numbers for you guys after lunch. Sorry about that, so drink your coffee. The higher the correlation there, the stronger things are associated. But what you could basically see is the association between people's attitude and the activities was much stronger. You can see how you can almost draw a diagonal line right there. So it suggests that maybe there's more corroboration between attitudes and activities than attitudes and the quiz results there. Okay, so this is in 2015. We found that quizzing was troubling, it was difficult to maintain that technology, not as much differentiation. Self-assessment using a rating scale was showing some promise, but we probably needed to come up with more items. And then the activity checklist, we thought, wow, it's pretty simple. It actually is correlating with another measure, giving us something to look into and is very quick to complete. So that was the end of study number 1. A year goes by, and we wanted to run another study. So here we are in 2016. So we refined the quiz, the activities, and we threw in a few more rating scale types. So we reduced that quiz. We still want to get rid of it. And we reduced the activity checklist as well because we're giving these people so many questions to self-report. So we added more of those rating scale items. You could get some idea here about what those are. How tech savvy are you? People often ask me for help in troubleshooting. I rarely need technical assistance. So again, classic approach at developing a questionnaire to assess sentiment and attitudes is that you come up with multiple ways of trying to capture that, with the idea being that you have a better chance of capturing that with multiple items than a singular item there. Okay, so what happened with our particular rating scales though? This is an example of something called a right map. You want to talk, Jim, about these? You love these right maps.
Yeah, so this is a, sorry, just stepping back real quickly. There's a type of scaling called Roche scaling, which primarily came out of education. And in its original form, you would have people responding to quizzes, for example, with yes and no, and then later is extended to allow, well, actually, yeah, with quizzes, so you're either right or wrong. And the idea is to have a bank of items that allows you to get behind the skill, let's say mathematics. So, maybe one item has something to do with, adding 2 simple questions, and something else may be finding the first derivative of some equation. And that with everything in between, then you get a good bank of items you can use to try to understand where the person is with regard to their mathematics skill. Um,
Yeah, no,
Later, people have applied that to attitudinal measurement. So what you're manipulating are trying to get questions that are easy to agree with and hard to agree with, and then get a good bank of questions that gives you good variation from easy to agree with to hard to agree with. And that's the representation you're seeing here. Normally, you would want to see those questions spread out more against that underlying scale. As it is, they're kind of bunched together. And what that means is it's not discriminating well.
Not discriminating well. These X's up here represent people's responses, and you can see all these items down here are only differentiating and kind of clustered in the average. So it's basically over measuring the sort of average tech savviness. So needed to get rid of some of them. They're not doing a good enough job of differentiating. What was interesting, though, is the activity checklist, that third approach, we found asking a subset of the same ones were actually quite similar year over year, really stable, even from a completely different population. You could see only by a single percentage point differences of what people, so few people could program, and a lot of people could still do some basic things like installing a new app on their phone and so forth. So that was encouraging. So at the end of 2016, this is what we had to look at. Not a lot of differentiating in those quizzes. We had some promise of the rating scales, but we know we had sort of two redundant items. We had to reduce those. And again, that activity checklist was the most promising approach. So here we are continuing down our journey. It looks like maybe the path to activity checklist might show the most promise, but rating scale is not so bad as well. So it's hard to talk about tech savviness by just having people answer questions on a survey or online. Why not bring them in and actually see tech savviness? To sort of paraphrase Justice Potter Stewart, you know, what is tech savviness? Well, you know it when you see it, right? So we wanted to see it. We brought people into our Milgram lab at our offices. No shocking here, but we had 50 participant volunteers come in, and we gave them a setup like this. We said, surely, if somebody's tech savvy, they should be able to accomplish this particular task. We had asked people, either Mac users or PC users, gave them a Mac or PC, gave them a cable, gave them a monitor, sort of like what our speakers have to go through ahead of time. Can you get it hooked up? Can you then reflect it to the screen, give them a YouTube task? All right, so if somebody could do this, they're probably reasonably tech savvy. If they can't do it, maybe not as tech savvy we thought. So what we did is ahead of time, before these folks came in, we gave them all those questions. We gave them the quiz, we gave them the rating scales, we gave them the activity checklist, and then we saw, can they actually do these, can they actually do this particular activity? So there's those rating scale items, there's the activity checklist. So what happened? People came in, most people are able to connect the TV to the cable. That's like the speaker task. So 89% of people are to do that. Getting the right source connected. I don't know if you've done this at home. It's like, why there's nothing showing up on my cable. That's a challenge. And then finally, getting YouTube open and then dragging it over to the other monitor. Only about half the participants were able to do that. We've got a couple anecdotes of people, you know, qualitatively describing the challenge that they went into. So again, these are all providing corroboration for our measure of tech savviness. Ultimately, we want to measure tech savviness that's good, not just because Jeff and Jim said it, but because the data supports it. And qualitatively, we should see that as well. So how predictive were those measures that we asked before we brought people in and tortured them in our lab? Well, here we have correlations again. These values are correlations. So a higher value goes up to 1, means perfect correlation. So anything positive means it's going in the right direction. Negative means it's going in the opposite direction. So what that means is the average of the rating scales correlated. So when people self-rated their tech savviness, it predicted whether or not they were able to actually complete those tech savvy tasks. But you'll notice the correlation was actually higher for the activity checklist. That was a better predictor. What about time on task? This was really not different than 0, so it was not great for rating scales, but it was actually in the right direction, meaning the more tech savvy somebody self-reported them in the activity checklist, the less time it took for them to actually get through those tasks. And then after each of those tasks, when they were in the lab, we gave them the single-ease question of how easy or difficult it was, and we found there was good correlation there as well. So we have good predictive validity with these measures, but even better predictive validity with the tech savvy checklist, the activity score there. So pretty cool what we got to do there. That's basically what we saw. Activity checklist, again, showing promise there. So moving on along in our journey of tech savviness, we've got some idea about what's going on here. Let's up the ante a little bit by really increasing the sample sizes there. We had, in that last study, we had 50 people. In the earlier studies, we had a few hundred. How about a few thousand? Again, this is fun things we get to do at Measuring You, is we get to collect large amounts of data and then provide it to all of you so you can learn from it. So we had 2 large samples of survey responses from the US. These were unmoderated studies we're going to be conducting. And what we wanted to know is if the activity checklist was showing the most promise, the most predictive validity, well, what activities, how many activities should there be? So we really wanted to refine that. So we did that. And here are those right maps again. We kind of blew them up. The software that you use gives you these outputs. You have to kind of really squint and look at it. But basically what we found was too much redundancy when you had 16 items, a little too sparse when we had only 9 items, and 10 was kind of like the Goldilocks zone, what we found there. The items were properly differentiating between people and at high and low levels there. So 10 seemed to be where we're at. Do you want to add anything to that, Jim?
Yeah.
That's pretty good.
Yeah, I guess, when, Jeff actually started this research before I joined Measuring You. So we've been working on, I've only been with this journey for about 5 years.
That's why it took 8 years. We
Yeah,
need you to join earlier, Johnson.
But when you're, like Jeff mentioned, when you're developing a scale, you try to add lots of items. And then you identify those that are redundant. And during scale development, we hadn't really run these right maps early on. So part of the movement to reduce the number of items took us from 16 to 9. And I don't know if you can tell from that, but HTML programming is one of the ones we removed. And it turns out that by putting it back in for TAC 10, that fills a fairly large gap between programming and the next activity down. So that's why I wanted to put it back in there, is to have something that helps fill that gap.
Yeah, we're talking about the TAC 10. So you've been very patient on our journey there. So now here's what we ended up with, the technical activity checklist, TAC 10. Jim gets credit for that cool acronym name, TAC 10. I think it sounds cool. So it's literally this simple. It's one item, and you're asking people in randomized order, you present these particular items, whether or not people can do it, and they can either do none or they can do all of it. And as you could see, as Jim said, understanding and using HTML was the question that we had sort of dropped, because we were just trying to make these questionnaires ahead of time shorter. So we had dropped that, but then we added it back in because it was not differentiating enough. So these are presented in the sequential difficulty, or a percentage of which people will actually select them. So it goes from most to least, or none of them at all as well there. So here's the TAC 10 activity checklist there. And so essentially this study with several thousand people that we found was the TAC 10 was the one that was best differentiating. And what's interesting about it too, somewhat unintentionally, we realized that this simple item not only could be used to assess tech savviness, but it also can be a way to identify sort of the bad actors, the people who are not really paying attention in a survey or a study. Because if you find yourself in a situation where people are saying that they can program in HTML or use HTML, program in Java, but they don't know how to install an app on their phone, for example, it just doesn't make sense. Maybe it's a mistake, but you get enough of those in there. If somebody's not paying attention or intentionally trying to deceive, that gives you some idea. So we're going to talk a little bit about how to score this shortly, but we weren't done validating yet. We wanted to continue to understand how the tech savviness now with these 10. So originally, those first studies, we were kind of tweaking it a little bit. Now we had it to 10, 10 and 9 in these larger studies. So we wanted to find out, let's subject this to more validation there. So across in-person studies, remote moderated, remote unmoderated studies, a few hundred to a few thousand people there as well. So 4 different types of studies, some of these difficult tasks, setting up a printer. So we're going to talk through the first one. We intentionally designed a study giving people very difficult tasks. The idea being we want to differentiate. We want this questionnaire to differentiate between people, and you need something that's rather challenging to do. So we did pay people for their time, but we asked them to do is first you have to kind of set up this task in Google Sheets, and then we wanted them to complete this online tutorial to learn Ruby on Rails, and they had to sort of solve these little things afterwards. Locate and upload a screenshot of the system's processor on your computer. You can see only about 46% of people were to get that. So we tried this out ahead of time with folks in our office. And then navigate to a difficult find page on a website. I think this was like a customer service number for the cable company or something. It was very difficult to find. So you could see only 35% of people could find that. So
52.
Oh yeah, 50, yeah, 35%. Sorry, yeah, 35%. About half people could find that there. So across all those, the average success rate is only about 35%. But you could see there, both the 9 version and the 10 version predicted or correlated well with their ultimate task success.
So we have a measure, again, that's being predicted. And when we saw this, that was just the first study. When we replicated this across people coming into our lab, setting up a printer, a streaming service, we all had positive correlations. And a good idea here of that average is, somewhere in between 0.11 and 0.64, about 0.3 here. So we've got a measure of tech savviness. Overall, what we're basically saying is our tech savviness measures are able to differentiate or identify about 22%, or predict 22% of the variation in task completion rates. And so in these particular studies, if a stakeholder wanted to say, well, how come people are failing? How much of that is how much of that is tech savviness? We basically say it's about 22% of that. We can explain away by tech savviness there. Now, every study is not necessarily going to be that. We intentionally made it difficult. You have to really be paying attention and be tech savvy to complete these tasks. So that's what we had to do here. So I think the final step that we wanted to go through was, if we have a measure of tech savviness, how can we really put this out there for easy use across the UX industry? And one of the approaches that we saw a lot with our clients is sort of classifying users into low and high tech savviness, just like we've been talking about today. Somebody's got either low tech savviness or high. Well, what's the threshold for that? How do you quantify low tech savviness and high tech savviness with this measure that we came up with there? So we used those same 4 studies, and we wanted to say, okay, where would we cut the data to say these people are high tech savvy, these are low tech savvy, but what about like in between tech savvy? How many levels should we have? Do we split the sample? Or do we split it by scores? Again, instead of just sort of flipping a coin, Jim and I try and use data wherever possible to make that particular decision there. And Jim, do you want to talk to us about how we first identified sort of low and high tech savviness here?
Yeah. One thing I should point out is, we've got a kind of distilled information here, but I think it's in a series of about, somewhere between 6 and 7 articles on our blog. We go into a lot more detail about each one of these steps that we've been covering. If you're interested, is measuringu.com, find the blogs, search for TAC 10, you should, be pulling some things up. All right. There are certain, high level statistical methods you can try to apply for classification. Discriminant analysis comes to mind. I played around with that some, but I didn't feel like I was particularly successful. Instead, we went ahead and took the scale that we had and took 2 approaches. I did certain cut points that were based on trying to say, okay, here's a sample. Where do I need to select it so it cuts the sample in half? I have the half of the sample with the higher scores, the other half of the sample with lower. That did not work well across all 4 of these cases that we're trying to come up with a single classification method to solve. But taking the scale and cutting it right about at the center seemed to do the job. And when you take a look at the low and high, I believe that the cut was if somebody had selected 0 to 5, then they were placed in the lower category, and 6 through 10 selections put them in the higher category. What we would expect, if this is reflecting some level of tech savviness that we can catch in success rates, then we should see the kind of stair steps that we see here. Now you can see the magnitude of the difference between the groups is not the same across all the studies. And I guess where the biggest magnitude is the study where the tasks were especially designed to be really hard. And so that's where we see this biggest step. But in general, that rather simple cut point, just placing it roughly at the center of the scale, gives you these kind of classifications. And each one of the studies, we see validation of that.
Yeah, and the way you look at this data here, this first study in particular, people who were low tech savvy had an average 13% success rate versus those who were high tech savvy, 57%. So that's like what, 4 times? You're 4 times more likely to complete a task if you're high tech savvy here. So we have good differentiating. But what about low, medium, and high tech savvy there? How is the differentiation there?
Yeah, well, again, you can go by populations, splitting the sample into trying to get 3 groups. That also didn't work very well there. Here, I adjusted the cut point a little bit, so it's 0 to 4. And you'll see a table of this later, so don't worry about memorizing it. but it's 0 to 4 for the low group. And then the remaining steps, cut about those in half to get a medium or intermediate and the high group. Again, if this is working, you want to see the stair steps so that as your measure of tech savviness increases, your success rate rises. You generally see that. You see it, you actually see that very well in the Center 2 studies, these, pretty big, substantial steps. In the first and fourth studies, we're not seeing as much discrimination between the intermediate and the high, but of course we continue to see decent discrimination with the low group.
And so what that means is, okay, I'm going to use the TAC 10. I want to classify my participants as low, medium, and high tech savvy, because then what you could say is, well, why the success rate is really low for this particular task. Maybe a stakeholder says, well, did we have tech savvy people? Did we have not tech savvy people? Maybe that was a problem. And it becomes a different story when you could say, look, we had low success rates with a high tech savvy group here. So this low, medium, and high is basically suggesting, at least with the data we had, that medium and a high weren't well differentiated. So it's that 2-level low and a high, which was differentiated. Now you can use the raw score, but if you want to classify, low and high seems to be the better bet than low, medium, and high. So here's essentially what we've got for across all those studies. You can see the average success rate for low tech savvy and high tech savvy across each study. I mean, that first one, 4.4, like I said. So people with high tech savviness were more than 4 times more likely to complete the task than low tech savvy.
Even though their success rates weren't spectacularly high.
Right. Even though their success rates weren't very high, we were still differentiating. And then these latter ones, even with rather large sample sizes, I think you're going to start to see things that you might see in a study that's not particularly designed, is that you're going to have some accountability of tech savviness, which is affecting things, but it shouldn't be overwhelmingly that difficult, that much differentiation, unless you're intentionally making things very difficult and then subjecting it to people who maybe are not as tech savvy. So overall, across those studies, people that are high tech savvy are 50% more likely to complete those tasks. So that's pretty interesting. Again, validating these measures, validating the approach that we took there. So this is just summarizing the scoring method. Essentially, to use the TAC 10, you just present that simple item, and then you score low as if they checked none, up to 5 is low tech savvy, which is pretty simple, and 6 to 10 is high tech savvy. The 3 group we've got in there, we haven't necessarily given up on it yet, but it's not necessarily now showing promise with the data that we've got. So there's the thresholds, and then one more time here, here's the TAC 10. Simple questionnaire, simple question. It takes 20 seconds for people to respond to that. It's pretty powerful. So we gave you the journey. You came along the journey with us so you could see all the things that we've tried, why this one was working. So you essentially present it in randomized order. You add up the numbers, and anything above 5 or greater, somebody is high tech savvy. And again, they shouldn't be picking things sort of haphazardly. That's some indication maybe. The unusual response pattern would be somebody who's maybe not paying attention. So that's the TAC 10. And
yeah. Oh yeah, just I forgot to mention, we also tried splitting into 5 categories, and that didn't work. So it just, there's not enough there to support that fine grain of a classification.
yeah, so here we are. We have the TAC 10, talked about the scoring mechanism. If you're familiar with MUIQ, our testing platform, we have this built in as a template. So it's a great way when somebody says, I want to measure tech savviness. This simple item here with that scoring mechanism provides that low and high threshold. And again, why are we doing this? We're not necessarily looking at assessing people for the sake of assessing people. We're using that either to screen or to classify after we've collected them. When somebody says, I need a high tech savvy group, or I don't want a bunch of high tech savvy people, how do you measure it? We recommend using this particular one, this particular item right here. And then when you collect the data, you can then essentially use this as a cross-tabbing variable. What was the success rate on you versus a competitor for both high tech savvy or low tech savvy? Sometimes you'll see sort of an interaction effect. Maybe it's some things get harder or easier depending on the savviness, depending on the interface there. So that's what we've got there. And we have, if you're interested, as Jim said, in more information about this, we've got this all over our website. We've got multiple articles, lots of sources, lots of data that we've exposed that you guys can get in there. If you like listening to Jim and I talk, we also give an annual boot camp every year. It's virtual. Someday we'll go back in person, but right now it's virtual. So for those of you who, and it's less of a boot camp now, and it's more of a, I guess, a course spread across a month on our Measuring University. And we talk a little bit about the tech savviness in our book that we just came out with on survey and the user experience, if you want to check that out as well. And I think we've got plenty of times for discussion and questions about tech savviness or anything in general. And if you guys don't have any questions, Jim and I will start throwing out our own questions. So I'm not sure the format. I'll hand it back to you, Carolyn. Do we just sort of pass the mic back to everybody when we have questions? All right. First question. And did you run these over to them or do we? Yeah. You're the mic runner. Okay, here you go.
Hi, Jim. Hi, Jeff. Thanks for the presentation. I have a bunch of questions, so I'll try to be short. Did you find any patterns of the sample regarding tech savviness? For example, age or gender, or I don't know. Did you find any patterns that could predict tech savviness?
I didn't look at those demographic variables. So when it comes to generalizing this, we certainly had the kind of mix of genders and ages that you would expect from an online panel for those studies that were conducted, unmoderated usability studies. For the moderated usability studies, I think, I don't know if there was an attempt to.
Well, actually, I know
anyway.
I guess, is my lapel not working anymore? I got to go in here. Okay, sure thing. So we do, as Jim said, we have enough data. We had enough differentiation in age, and we actually are starting to see a small effect with age. So as sort of the anecdote that started today's talk, we did see a little bit of a dip. Age did explain it a little bit at the periphery. It's still kind of preliminary data that we haven't quite published yet because most of the data we had was within a much lower range. But this corroborates, I think, when you look at demographic differences across all UX metrics, this one comes up a lot, like age, gender, certain geographic. Only in certain extremes do we typically see differences or certain variation. And so we're expecting there to be a little bit of an age effect, but as Jim is a good example of, it's confounded by other factors. These, in many cases, our older folks are very tech savvy, but there's a little bit, especially as the sample size gets larger.
But yeah, it certainly, seems like a good thing to look at.
Yeah, but no gender differences that came up as well.
Okay, and my second question. Did you see, have you done any research with AI-related capabilities, skills with people or activities? And because I have the perception, this is just intuition, but that especially in AI, you have a barrier, a friction of perceived use that you are not going to be able to do it. Have you done that? And did you see that barrier in the studies you made?
Well, I'd say that the AI popping up as a topic is relatively recent. Remember, this journey started
2015.
In 2015. The other thing is AI is spread out all over the place. It's one level of tech savviness to type a prompt into Chat GPT, and it's, a different level of tech savviness to, work with the programming that scrapes the web to create the models. So, that's a long way of saying, I don't know, not yet.
Yeah, not yet specifically for AI, but I think one thing we do want to add, we've had some discussions with folks about specific populations. And I think one thing to keep in mind, if you're wanting to use the TAC-10 to measure tech savviness, this was validated using a general population. So for example, somebody asked, well, I have a group of programmers, for example. So how would I be able to differentiate the tech savviness of those programmers in their TAC-10? And the short answer is you won't. This wasn't developed to differentiate between tech savviness with a very specific population. It's either high or low. It's sort of like saying, how should I determine what's high or low? And then my population, which I'm going to assess, is just NBA players. You're like, well, they're all really tall. So you've already got a sliver of the population that you're working with there. And it's the same thing with tech savviness. If you're like, I'm only working with programmers, everybody's going to check the top two boxes. Now, a few of them might not check a couple things here and there, maybe printers or so forth, but they're probably going to fall into the high tech savviness group there. Same thing about what about older folks who are maybe not even on the internet, or marginalized folks who have difficulty with technology, not validated against this. They might not check any of these things. So we really wanted something which accounted for a large portion, but certainly not all. We couldn't quite get there yet. But what's nice about this measure is it's so compact is that you can supplement it with a specialized population measure. If you are measuring programmers, maybe it's a very specific set of AI questions that you want to differentiate, or maybe it's something very specific for an elderly population that you would want to differentiate. Easy to add on. So it can't do everything, but it does good for the sort of middle part there.
Maybe this is in one of your articles, but I'll ask it anyway. As you get more and more people going through the Tech 10, if you were to sort of look at the distribution of tech savviness, what does that look like? Is it a smoothly descending line? Is it lumpy? Is it a bell curve?
That's a good question.
Yeah. Well, the way that Roche scaling works is, we're talking about producing a score that's just counting the number of check boxes, but those fall into a particular place on a logarithmic scale from, about 6 logs down to 6 logs up, or something like that across the population. The items themselves are a little more constrained than that. And so I believe that we have published the actual percentages from some of the large scale stuff that we have, so that with the 10 items we've got now, it's a relatively smooth scale. And the reason I say that is because we know, the upper bound is at, professional programming basically, and the lower bound is at, what's the low item? I can't even remember now.
Yeah.
Like it's basically, yeah, but basically the percentages go from like the 90s down to around maybe 15% of the population that we've worked with. So it's, I won't say that it's perfectly linear. It might be log linear.
Yeah, and I think just building on that, we have a large enough data set too that I think it gives us a good idea to publish some of that out there. What do we see as a typical distribution in a study by score? I think an earlier discussion we have somebody too was just being able to say, well, how many people actually select none of those things? And I know it's a very small percent, especially because how we're collecting people is that we didn't knock on doors and say answer our tech savvy. They had to volunteer to get paid in an online panel there. So you're already dealing with a sort of censored population.
But then again, yeah, those are the censored populations that we make a lot of our decisions from. So, yeah.
Hi, I just had a quick question. For study 2, it seemed like there was some clear stratification for that medium category, especially when you take a look at that compared to like the study 1 and study 4. That was obviously a little bit more muddy. Did you look further into what might have caused that stratification to be clear for that task?
Mostly no. But I guess we can maybe do some speculation. Part of one thing that makes me happy about the 4 studies that we're using to try to validate this is the amount of variation that we've got in terms of task and method. 2 of the studies were in lab moderated studies. 2 of them were unmoderated remote usability studies. I think your earliest one was done with Amazon Turk, was the basically the source. Now it's more, I don't want to say professional panels from companies that that do this for a living, that curate and do it for a living. But to answer that question, you probably need a lot more examples. So we've got 4, and I think that they're well spread out. But when it comes to zooming in and then trying to explain some of the idiosyncratic results, there may not be sufficient data to really do much with that yet.
Remind me in what year you established TAC 10, the 10 items?
Oh,
The data started in 2015, but I believe probably 2021, 2022 is when we started.
Okay. And yeah, so follow-up question is, have any of the items changed over time, and like how so?
Couldn't have planted a better question than that. Good one. So I think
get your dollar later.
yeah, right. Yeah, so right early on, and we were sort of chuckling at the Chromebook and the Ultrabook and the 1080p, but now we've got this activity checklist, and so it's like, what about those activities? How are those going to go away? I think there's a couple things. One, I don't think enough time has gone by. So I think to your earlier question about how old this was, so only a couple of years. But what we've already modified to it, so we talked about Excel formulas. We've already changed that to spreadsheets, Google Sheets or Excel spreadsheets. That was an easy one, and we feel pretty good that those are never going away. So that seems to be a sort of a consistent differentiator. We have the programming language is also going to become generified. It's not just Java, but we gave that as an example. And what was interesting is Jim and I talked about the sort of longevity of this. And so anytime you have a standardized test, you have sort of to go back and look at the items that are getting stale. What's nice is certainly the way that these are classified. If we find ourselves getting to a point where these items no longer make sense, something about maybe printers or viruses, you could see a day maybe when those won't be difficult for people to deal with, but it's going to be a while. We feel like this instrument we can easily insert and replace items. And what's nice is that you still have the continuity of low and high tech savviness. It can sustain enough sort of changes, and you still have that above 5 and below 5 threshold as long as things don't change too much.
Yeah, I think that's that's certainly the case. And in some ways, I mean, we still have our original source of about 16 items. Now, I threw a bunch of those out to get to 10, but it was like coin tossing. Well, it was a little more than coin tossing. I actually was trying to select the ones that we thought would have the best longevity. But it's, when it comes to just trying to get the percentages on something like this, I wouldn't say that it was trivial to collect 10,000 cases, but I mean, as you demonstrated, it's certainly possible. And then from that to have, new candidates in there, be able to set up the right map and see, what the gaps look like and get to something that has gaps, a range and gaps similar to the TAC 10 that we have. And then that should work out pretty well.
Yeah, I mean, you could sort of see not too distant future of maybe a question about somebody's ability to prompt AI or ChatGPT type of things. And the question becomes, okay, how much does that differentiate more or less than any of the other items that would be in there? And so that would be the process by which we would see, is it time to replace something that we need to differentiate, or is something becoming kind of too stale?
Hi, I have a question regarding, do you see any variances in the results for different industries where it has different baseline for what tech savviness means? For example, I work in the gaming industry, so tech savviness may mean that they have the capability of setting up a console in a home, whereas I used to work for a media company where maybe it's opening up app, maybe it's browsing the app can be considered as a baseline for its tech savviness. So I'm wondering, do you account for that in your survey, and how do you see the differences or similarities?
Yeah, good question. I think that builds on kind of the earlier point. So two things. I think the gaming population, we would classify that as a sort of a specialized population. If you can essentially develop your own gaming console, my boys rigged out their computer and so forth. So there's a certain threshold that you're already dealing with right there. We don't have enough data to necessarily say, here's the sort of average score for say, gaming versus the general consumer industry yet, other than to say, we would expect that to be very high. And in those particular cases, there's often less need to then identify tech savviness. It's sort of a presumption that if you qualify for a study with us because you use this or do this, then you have enough of what it takes. The question, I think, comes up a lot more when you're dealing with the general population, streaming and hardware devices and so forth, where you're dealing with people who don't necessarily spend a lot of time with computers and technology. And so it's certainly an open question what those baselines look across industries, and maybe we'll get there. Or even across UX studies, what's a typical tech savvy participant? So if somebody's trying to calibrate their study, that's a good open research question as well.
Sorry if I missed this. How did you come up with, like, I guess, like, not like the topics per se? You asked no question, but like the wording per se, just making sure people understood, like, I guess, like what you were asking, like when you.
Yeah, how did we come up with the wording for the
Yeah.
TAC 10 or anything? Yeah, so across all of these, it's a little bit of when we looked back at that earlier literature, certainly for the rating scale type data, we're like, all right, here's some phrases that are being used and the technology that's being used. The quizzes themselves, we sort of put our head together and said, okay, let's come up with one, let's come up with a distractor. Sort of shows how hard it is to work with quizzes in general. You got to come up with that. What was nice about the activity checklist is that we felt the wording was a little less subjective. I mean, there's certainly something that we were tweaking in terms of how we described it, but at the end of the day, you're describing a virus, you're describing a printer, you're describing programming, HTML. And so we tried to keep the language simple, but there was not necessarily, you want to build on that?
Oh, I was just going to say, I mean, you know, I don't think you'll see any, particularly highly technical words in there, except if someone says, well, what's HTML? Then they have no business checking the box.
Yeah.
So,
Yeah, and it was interesting, and I think one of the reasons we dropped HTML is because we thought that was too specific of a technology, and it's like over time we feel like even though HTML is probably not going away for years, it's going to become more and more sort of part of programming frameworks that people think a lot less about, and that's why we originally dropped it. But then it turned out it actually was still differentiating, so that might be one of our candidates eventually that goes out. But right now it's still there.
Maybe just say markup language, but now who knows what a markup language is?
Yes.
So
Yeah.
that's
And I'm thinking just the example like HDMI, like 10 years ago, I feel like a lot of people now, like, everybody can just stream or, like YouTube or like on their TV or something like that. So I feel like streaming is a much more common. So I think over time, and I love what you're saying, like these words change in, expertise and everything. People are familiar. So.
Yeah, there you go. Yeah.
Sorry, one more. So as you've been using the TAC 10, have there been any interesting cases of inverse correlation between tech savviness and task success that you've seen? Kind of like a curse of knowledge type thing. And answer can always be no, right? But that you found that we might be able to learn from and apply elsewhere.
I didn't quite. Sorry, I didn't quite catch it.
Yeah, I think there was a little reverb from the speakers. I think so. The question is, in using the TAC 10 for extra data, any interesting findings that we found basically with it? Inverse correlations, you said? Nothing quite like that. I think so far what we've basically seen is, I think Jim and I were really happy to see that we could predict task completion rates with something. And so, and then it seemed to go in the directions that we expect. What you end up seeing is somebody's success rate, as we see with typical UX metrics, correlates with their time on task, with their attitude. So you've got this, things just started making sense. People who are more tech savvy had an easier time in these usability tests. It was reflected, and we had a lever we felt like we could push if we needed to say, well, what does that study results look like if we didn't have high tech savvy participants? And that's the real advantage here. So no real surprises yet, nothing unusual other than I think just the satisfaction knowing that we're capturing this sort of construct that I know it's been sort of difficult to nail down beyond a sort of simple self-report that people had and just sort of picking a top box and so forth. But I don't think there's anything else you want to add that.
No. I guess when you're talking about the inverse correlations, that kind of like the how often people feel like they see someone succeed at a task and fail at a task and then give it a high rating or something like that. And Jeff and I actually looked at that. What was that? Maybe 2010 or something like that. No, 2009. In just looking at correlations among prototypical usability metrics. And it turns out that that's actually not the case when you look at a large body of data. There is a positive correlation between success and people's ratings of the tasks that they did. Is it a perfect correlation? No. But it's still, it makes sense. And when you're confronted with someone, it's so compelling when you're in the lab and you're watching someone absolutely tearing their hair out and then you say, well, what was your experience like? Oh, you guys got it. It was the most wonderful thing I ever saw. Although you do occasionally get comments. This is one when I was working at State Farm. We ran a study once, and I think the response was, it wasn't the worst experience of my life. But so, but anyway, it's just like, all the cars go by on the road, nobody crashes, you don't notice it, and then when the cars crash, all of a sudden you're alerted to it. So that's part of it. But no, I don't think we haven't seen anything crazy like that yet. And the other thing is about 22% of variance explained. Why not 100% of variance explained? Well, we're just delighted that it isn't zero. When you can explain almost, over 20% of the variation in an outcome variable with something as simple as this, and it's a simple outcome, it's a simple binary outcome variable, we're pretty happy about that.
Yeah, and I think building on that too, we didn't want to measure that explained 100% of the variation, because that basically means your usability test is just testing tech savviness, and we'd all be without a job, because then we're just measuring tech savviness. So we knew there would be an upper bound there. So on one hand, what we're seeing is really the place where tech savviness best explained task success was in a study that we specifically designed to be very difficult, or only the most vigilant people would follow instructions and understand the nuances of the technical task that was put in front of them there. So the other studies where we saw the differentiation, 10 to 15% of the difference in task completion rates can be explained by tech savviness. That feels about right from our experience. It plays a role, but it doesn't play nearly as much role as the interface does and why people succeed or fail, or prior experience with the interface. I don't know if we have time for one more question or we're wrapped here. If there's any more questions, if not, it's good. Okay. Yeah, if we didn't get to your question, Jim and I will be hanging out over at the Measuring You booth. Feel free to come by, say hi, and we'll tell you some stories and have a drink later on. So, all right. Thank you all very much for coming today. All right. Okay. A wrap. I'll get all this technology down.